All right, good day. So, today we'll be looking at trigonometry, right? Trigonometry. And trigonometry is a very long and robust topic, right? When we are talking about trigonometry, we're always dealing with triangles. But today we'll be doing something on special angles, right? Special angles of 30, 45, 60. Right? Sometimes you don't need to use your calculator before you know these special angles. So I'll show you how to derive these special angles, and we have the main three functions. We have main three ratios rather. We have sine, cos, tan, right? We also have cosecant, which is the inverse of sine. We have secant, which is the inverse of cos, and we have cotangent, which is the inverse of tangent. So um, but let's just work with this, right? Let's work with this. So now, if you remember the logic, so swa, right? S means sine, right? Sine means opposite over hypotenuse. Ka means cos, adjacent over hypotenuse. Swa means tan, opposite over what? Adjacent. So when we are dealing with um sine, cos, tan, we need to look at a right angle triangle. But first, let's look at this. Let's assume this is an equilateral triangle, meaning all the sides are equal. If all the sides are equal, it means all the angles are what? Equal. So let's give an assumption that each sides have two. Each sides have two. If I divide this into equal half, right, we get this. This place will be what? Angle 90, right? And if we divide 60, 30, this one still remains what? 60. Now, here will be 2, here will be 1, because we divided into 2 equal half. How do we get this place? If you remember your Pythagoras theorem, right, which is hypotenuse square equals to opposite square plus adjacent square. The hypotenuse is the longest side, 2 square. Now, we can take anyone as opposite, anyone as adjacent at this point, because here this is the opposite. But if I using this angle, this is the adjacent. Opposite, whenever you want to know the opposite side, the angle which the side is facing is the opposite side. For example, for 60, this is the opposite of 60. For 30, this is the opposite of 30. So the other one will be, if this is the opposite of 60, then this is the adjacent of 60. If this is the opposite of 30, this is the adjacent of 30. But let's take it as anyone. Let's take it as 60. So opposite is opposite square equals plus 1 square. So we have 4 minus 1, right? Opposite square. So we have opposite square equals to 3. So opposite will be what? Root 3. So here will give us what? Root 3. Here will give us root 3. So how do we now know our sine 30 and sine 60? Well, let's start from 30. For 30, this is our opposite, this is our adjacent, and this is our hypotenuse. So sine 30, sine is what? Opposite over hypotenuse. Sine opposite over hypotenuse. So our sine 30 is what? 1 over 2. 1 over 2. Let's go to cos. Adjacent over hypotenuse. For 30, this is adjacent over hypotenuse. So root 3 over 2. Root 3 over 2. Then our tan Tan is what? Opposite over adjacent. Opposite over adjacent. 1 over root 3. Are we getting it? So now if I see 60, for 60, these are our opposite, these are our adjacent, these are our hypotenuse. So sine 60, opposite over hypotenuse, root 3 over 2 over 2. For, sorry, for, oh wait, for cos, adjacent over hypotenuse, adjacent over hypotenuse, 1 over 2. Then opposite, tan opposite over what? Adjacent, root 3 over 1, which is root 3, right? So that's how we get our 30/60. So most times, if you check your calculator, 1 over 2 is 0.5. So you do sine 30 or you do cos 60 to give you 0.5 or 1 over 2. Root 3 over 2 is 0.8660. So if you type it, that's what it give you. So there are times where you are doing calculation, you don't really have to quickly look for calculator. Just know, I'm using sine 30 here, 1 over 2. So you now click. Then for 45, right? 45, we're using a right angle triangle, which is isosceles. Don't worry, I will explain. A right angle isosceles triangle. So let me clean this since we've figured out for 30 and 45, right? 30 and 60 rather. So for angle 45, right? We're using a right angle triangle, right? But in this right angle triangle, these two sides are equal. If these two sides are equal, it means these two angles are equal. If this is 90 and the sum of angle in the triangle is 180, if you remove 90 from 180, we will have what? 90. If these two are equal, it means we are sharing it divided by 2. 90 divided by 2, we have 45, and we have what? 45. Are we following? So let's assume we have what lie is now. Let's assume we have 1 each. 1 each. So how do we get this same place? The same way we did. Hypotenuse square equals to opposite square plus adjacent square. Hypotenuse square equals to 1 square plus 1 square. Hypotenuse square equals to 1 plus 1. Hypotenuse square equals to 2. Hypotenuse is equals to root 2. So put our root 2. So here, anyhow we do it, will still work. If we take this as opposite, take this as opposite, it's still the same thing. But let's look at it. Sine, let's take this as opposite, but it's the same thing. Sine 45, 1 over root 2, opposite over hypotenuse, 1 over root 2. Cos 45, adjacent over hypotenuse, 1 over root 2. Then tan 45, opposite over adjacent, 1 over 1, that's 1. You get it? So these are what we call special angles. Special angles, right? So special angles, you just need to know this. Most times, if you understand mathematics, you know that these are what we call short form, and your denominator, you don't leave your answer in short form. So even in as much as you have this can also be root 2 over 2, root 2 over 2. This one, this one will be root 3 over 3. You get it? So, but for the special angles, it is allowed to leave it like this. So that's all for special angles. In the next video, we'll dive deep into trigonometry. Thank you.